Okay, so this morning we're going to cover automation and orchestration, and we'll do 3 modules. We'll kind of break this up into 3 parts. One is the kind of first stage. We'll talk about kind of an imperative model, but we'll have a little bit of history in that section also, and cover a couple things. We have a lab in each section. In the first lab, you'll get acquainted with the REST API for BigIP, and you'll also use a tool called Postman to issue those REST API calls and get some practice with that. Second, we'll come back and we'll talk about what we'll call orchestration, where you're in the imperative model, you have to know or understand the device and or the ways that you talk to the device in a very deep knowledge level. Declarative, you want to get to the point when you're orchestrating where you don't have to know as much about the device. You can just issue calls, and so in that section we'll talk number 1 about the declarative model, but also about AS3 and Ansible a little bit, and we'll do a lab using those two things. Tomorrow morning, we'll come back and we'll finish this out with BigIP Cloud Edition and give you a little bit of experience on how to have BigIQ issue using a template, issue those REST API calls, and create applications on BigIP in kind of an orchestrated way also. So we'll come back and cover that tomorrow morning. Okay? So first, let's talk kind of a little history, and maybe the best place to start is a little bit of terminology. Private cloud really is just meant to talk about the traditional data center, but in a virtualized format. So you have all your apps running on your private cloud now. The only difference is it's on hardware that you're using virtualization to kind of do a lot of the stuff that you typically did on special purpose hardware. Public cloud, or the AWS and Azures of the world, where you're paying somebody basically to run your stuff or your applications on their hardware, right? And they're able to make money on that. That's the thing that has changed drastically over the last X number of years. They're making money on that because they can do the same thing, virtualization, but have that hardware be pretty efficiently used. Your app running first, and then if you pull out and you don't need any more services, they can put somebody else there, right? So there's a benefit to those cloud providers that they're trying to make a buck on, and yet for you might be able to get away running stuff on the public cloud a little bit cheaper than what you might on your own private cloud. And in hybrid, many customers are doing a mix. Right, they have things in different places. In many cases, they might start their applications out in the public cloud, and then at some point, if they get to the point where they think we have a lot of volume with this app, we could probably do it more efficiently ourselves than paying AWS this huge amount of money to go do it for us. So there's examples such as Dropbox that grew, and at some point they looked at their AWS bill. They started in AWS. That's where Dropbox started. At some point they looked at their AWS bill and decided we could actually probably do this cheaper ourselves. It was hard, but they got it back to a private cloud scenario where they're now doing everything in their own data centers as a private cloud type of environment. So it's interesting to watch how companies are approaching this. Some of them are trying to just get to cloud, right? And some of them are kind of half in, half out. It'll be interesting to see where it ends up. We've seen this movement back and forth many times in our industry for a lot of different reasons. When you think about some of the reasons why customers are doing cloud stuff, if you think about the way they traditionally deployed applications, they first, on old traditional data center stuff, they had to go ask the network team for resources, the server team, the storage team, right? And then finally, once they did all that, they probably had to buy some needed hardware. And then finally they could build their app and start testing. That was a long, very involved time frame to be able to get to that point. So a lot of the reasons why customers are moving to the cloud are these type of things. We need to get this set of apps running a lot faster than what it took us before. So that's a lot of the kind of previous regime. Now, why cloud? In many cases it might be we're only going to use this for a certain period of time, so renting rather than buying hardware is going to be a better alternative for us, but not always. Cost is not, in the end, always end up being a good reason to move to the cloud. Speed to market, though, almost always is. And by speed to market, we're talking from weeks to a day, or even in a set of hours, being able to get a new app up and running in the public cloud, where you just couldn't do that previously. It was not possible. Now, private cloud, on their hardware in their data center, they're able to do that, but virtualization has allowed that to speed up. And not everybody wants to do all the management of private cloud. They want to let somebody else do that, at least until they decide that that application is going to take off and we need to have more resource for it, and we don't want to pay somebody else. Good? How do you get that? If you're going to try and do these things faster, there's things that really almost have to happen. One is you have to automate. You just can't get away with without automating if you're going to try and achieve that speed. And there's different automation tools that different companies are using or customers are using, such as Puppet, Ansible. You often, where people are trying to get to is some of these container platforms and just a more efficient use of the hardware resources such as CPU and RAM in a containers environment versus total virtualization. And then often you're running on one of those public cloud environments. Right, so in order to get that speed, this is where a lot of customers end up needing to go train themselves and push their apps to a different model. And that's where a lot of them are. So we're having to go learn this. I equate this for you guys as SEs to years and years ago when people used to network operators used to come in and learn about big IP LTM. I would tell them, you can stay at layer 2, layer 3, but I would suggest you start learning 4 and above. Learn about HTTP. How does HTTP work? Right? Not everybody did that. The layer 2, 3 guys, I just want to stay layer 2, 3. Their job opportunities became more and more narrow with what they could go to. The guys that learned HTTP had more options. Some of them left and went to apps groups. This is the same type thing. We're not necessarily asking all of you to become DevOps experts, but at least know how to talk to these people and understand their language, understand the platforms they're using. Just get your schooling done on some of this stuff so that you can kind of be able to converse better with them and start the conversations. Okay? Well, over time, I think we'll develop a lot more expertise in the SE ranks, but not necessarily everybody will know everything about DevOps, I think, for at least a while. So, what is automation and orchestration? We always could do this. How did we do it in the past? Command line, right? Not necessarily iRules. iRules are more for changing how the traffic's processed. We're talking about setup and teardown of the configuration. So setup and teardown of the configuration, a virtual, a pool, taking pool members in and out of service, things like that. We always could automate. We had to do it with command line scripts. How would the big IP admins do that? They'd write this command line script and hand it off to the operations folks and say, run this during our maintenance window, right? That's automation and orchestration, but big IP admins, the TMSH commands were very, very complex. They had to know how big IP worked. A lot of knowledge had to be in that person for them to be able to automate and orchestrate, right? But you could always do it, and yet it was not easy, right? We want to make that easier. Now what we've added is this REST API to Big IP, because that's what a lot of DevOps groups are using, is a REST API. They know how REST API, how many have messed around with REST APIs? Okay, cool. I'd say 2 years ago, one hand would have gone up in a class of new SEs. So we got a lot of people with the background now. REST APIs are easier to go teach people now because they're coming from the background of web applications, and a REST API uses the same or similar HTTP command as HTTP commands and response codes, and we'll talk about that a little bit later before we get to lab. But that's why we went that way. Big IP Cloud Edition we'll talk about tomorrow morning, but it has application templates that you can use to kind of script and build a set of apps, which under the covers for us means a virtual server and profiles and pool members and stuff on Big IP, right? So we'll talk about that tomorrow. Future, really where we're headed is blue. Right now this Big IP thing, this TMOS or full proxy architecture is a little bit bigger than what customers would like in terms of how much resource it needs. Now we've worked for years adding more things to this. We added ASM, we added APM, and this code grew, right? Now what they're wanting, we want just the proxy, or we want just ASM. So now we're breaking things apart into smaller pieces for being able to do things like containers and microservices, and that's kind of where blue is headed, which you'll hear more about in the near future. Okay? Questions? You guys are quiet. So really, in the end, I think it's important to think about, so what? All this automation stuff that customers are doing, where does F5 play? How do we still have a play in that? I think about it, for me, what's made the most sense is to think about it in terms of the full proxy, and I think there's still value in sitting in between the clients and the apps. I think we can provide a lot of value in that scenario. Number one, if you're using a Big AP in either public cloud or private cloud or traditional hardware, so VEs, it all looks the same, right? When you're configuring either LTM or ASM, it all looks the same, no matter where you're doing that in private or public cloud or hardware. And also across the same clouds, right? So you can do, a Big AP looks the same on AWS as it does in Azure. If you're using their load balancers and you decide you want to move clouds, it's pretty difficult to do, right? You've got to go learn the new load balancer for the new cloud provider, where if you're doing us, for instance, with ASM, if you're using us as the WAF, looks the same on every single cloud. Proxy between, I think there's still a lot of value that we can provide as a intermediary between the clients and their applications. For instance, we've always talked about TCP services. Those clients are going to be coming from all around the world, and I think we can maximize or optimize for some of the TCP services when they get to the apps in the cloud. Same thing. We can offload SSL. Right? We've always done that. I think we're very, very efficient, very, very fast at doing that. So that still plays for those applications. If you think about what APM does, there's a huge amount of value. Maybe they don't want their Active Directory server in the cloud. They still want it on-prem, but they want to be able to have these applications be, or the users check before they actually get to them. How are they going to do that? So we could be the intermediary and send the request. Once they hit Big IP, send the request off to their Active Directory server on a different cloud or in their private data center, and then decide to allow them or not. A lot of value there. ASM, same type idea, right? Look at the content, terminate SSL, look at the content, and decide whether we want to allow them or whether they're an attacker and we want to block them at the application layer, right? And allow them through or not. So I think there's the other thing I'll pitch is, as a proxy, just sitting in between. If you guys have heard, and I mentioned this the other day, if you've heard of a network tap right, where a device is sitting in the middle and looking at all the traffic going by. As a proxy, I think we can do some of that same stuff and decide for the applications groups, that particular application isn't running real well because, and here's a suggestion, it would be better if you did TCP WAN optimized services on the outside with your clients. Or a lot of them are coming in as IPv6. We can be the broker in between, and you don't want to do IPv6 on your app. All sorts of things that are options there. We've talked about this, but I think that's where we play. Public cloud, all we're doing is replacing that hardware with a VE. Same thing, right? This is you guys will see this, I think, in the future coming up if you haven't already. An interesting way to describe where we're headed, where F5 is headed. We've traditionally played in those more complex, higher cost of ownership apps in the data center, and we've done a very good job there. Where a lot of customers are trying, where we're missing out on applications, though, is all these hundreds or thousands of other applications that the customers have that don't need that very high performance, but also high cost. They don't need that for many of their applications. And we haven't really done a lot. Historically, we haven't really done a lot with those applications. So we first came out with Big IP Cloud Edition, and that was our kind of half step to be able to go start talking with customers about where we're headed. We're not, it's not really where we need to get to over here. It was a half step to be able to start having those conversations with customers about some of these other applications that they have out there. Take it a little bit further, Blue, where it's more cloud native type of application services, is coming in the very near future here to be able to address a lot more of the apps that the customers have out there. Who we traditionally talked to back here were the network operations folks. Not necessarily in this scenario, right? We're talking more to the DevOps. Question? Or just comment? Yeah.
Be more of the on-prem.
Yep.
And having conference application, it would be faster and simpler. Or faster and simpler when we go to cloud.
Yep.
For different audience.
Different audience, I agree. Yep. And then ultimately where this is headed is as a service, right? So we have these F5 cloud services that we'll talk more about in the future, that we can offer DNS as a service, for instance, and they go to F5 in our data centers, just change the traffic path, right? And we'll answer the DNS questions for them rather than them going to some provider. Okay, so we'll continue to add to our offerings over here also. But traditionally, we've been over here. We're trying to add to our ability to talk to customers about other stuff because we think we have a good solution for them in many, many cases. But we're getting there gradually, right? Right now we've announced and made available Cloud Edition. In the very near future coming is Blue, so this section here, and we'll just continue to add to this as we go. Have you guys seen this graph before, or this picture? I think it's a good way to describe kind of where we're headed. Interesting times. Another thing we need to talk about from a kind of historical perspective is the idea of microservices, and we're not going to do a huge class on this right now, but traditionally a lot of stuff has been in more of a monolithic type of model where it's one big chunk. Big IP is a good example of that, right? It's grown. We've added more and more to it, but it's gotten bigger and bigger and more code. Now where customers want to go to is microservices, where they're just, one of these little chunks might be the WAF, in our case advanced WAF, but maybe they've decided I'm going to add that later, so right now I don't need that. I don't want it. Right? That's more code bloat that they don't want right now. Later I need to add that, but I'm going to add it when I'm ready for it or when I need it. So they add it in smaller chunks. The footprint is smaller. The cost in public cloud is smaller, right? Then when we grow, we'll add the things that we need as we need them, but not until. Make sense? Maybe another view of this same idea, kind of, and we've got one more view of the same idea. In traditional, the monolithic app, you often talked about 3 tiers, right? You had the web tier first, then the app tier, and then the database tier, right? Different view when you start talking about microservices. You might have pieces of that in different parts of the application, but some apps may not have any of one of these things, right? And you can also reuse these things. The pieces can be reused by different applications, potentially, depending on how the apps are written. Okay? So just a different view of kind of the same thing. Containers is another thing we need to kind of talk about, at least for a second here. In virtualization, what traditionally has happened is you've had virtualization still runs on hardware. I think there's times where people forget that. There's still hardware that's running everything, right? But you have an OS and then a hypervisor, and then underneath that, traditionally you had an operating system for each guest, right? Containers is a whole different idea. We're trying to get rid of some of the fat or resource needed for that type of picture and go to more of a one operating system for the whole thing, and then just these little mini container environments that don't need the whole new OS. Chris, is there anything you would add to the containers discussion for now? Okay. Okay. Yeah.
Yeah, one of the big concerns with security professionals and containerization is how these different container platforms truly segment off traffic. So that's something that the industry, and at least from a security perspective, is having to kind of embrace.
There's embrace is a good word. This is a big shift, right? I mean, it's not just something you do overnight, and I think a lot of companies are getting into this realm and discovering, this isn't as easy as we thought.
Yeah, the exact issue is that one flaw with the container platform exposes everything on there.
Yep.
Where you can patch the operating system. So.
Yep.
Well, it's not completely true, because when you run container, each environment that you do of the container is separated from the other. So it's not that if you have a flow in Kubernetes that is doing, for example, governance for the container, you can access each and every container.
Yep.
The container by itself, it cannot even be accessed because it's not an OS, it's not a VM.
Right.
You have a lot of functions that are completely disabled. So security is much stronger in containers. The reality is, what he was saying, if you want to reuse a container, maybe you have a DB container that can use for this service and for this other service, in that case you have to do service mesh and you have to expose the same function. In that case, there are security aspects that Postman can have.
Where they're crossed, yeah. Yep.
I would debate you, but not now.
And I mean, there's times where this is going to get into religious wars, right? Just like Mac versus Windows. I mean, there's definite opinions and different ways to go.
It's the fine points.
Yeah.
It's just,
Yeah.
You're right. You're by and large, you're 100% correct. It's the fine points.
Yeah.
This is the kind of conversation that security people are having at the moment.
Yep. Yeah. Yeah, because the whole idea behind some of the security stuff, or just how you're going to build your app, changes in this picture. So it's a different model. Okay, so is one of those different container environments. Supernet Ops is another thing that we need to talk about in this discussion, and Supernet Ops is just a F5 term. How many have already heard kind of a good explanation of Supernet Ops? Okay, so a few, not everybody. Interesting. The idea is when we first start trying to get into this F5, we first try and get into this discussion with DevOps groups, we haven't traditionally talked to them. And so how are we going to bridge that gap? If we want to move that way, maybe talking directly to the DevOps people is not the right thing to do. So Supernet Ops is our way of thinking through how we're going to start to engage these other groups, okay? First, we've got a few things that we need to mention. Traditionally, we had applications developed in a very different way, kind of a waterfall development. Now, a lot of teams are moving to agile development. It's just, again, kind of a different philosophy between the two. Agile says hence the reason for this infinity term is it's always changing. We're always making modifications, but they're often smaller changes, right? Here, we wait for a maintenance window, we do a bunch, and if we don't make it work, we roll back, right? There's no real rollback over here.
It's less secure.
It's pave and nuke, right? I mean, we make changes all the time, and if we find errors, we fix the errors and keep moving forwards. That's another change, and another change, and another change. And if they're small enough, then the hope is that that'll be the same impact, and we'll be able to move forward faster. That's the idea. I think companies are going to go over to this side, and then at some point they're going to go, okay, there is reasons why we have these change management ideas, and they're going to end up somewhere back in the middle. Right? Can't go this slow anymore. It's not going to work. You're going to get put out of business. Our apps are really becoming part of the business, and if you go this slow, you're just not going to be able to keep up. So they're going to move this way, but then I'm guessing that we're going to end up somewhere back in the middle. Kind of, but it'll be a whole different paradigm at that point. So Supernet Ops says, over time, what we're thinking will happen is a lot of customers will move, and this is a little bit dated here, but a lot of these different applications, from the mission critical ones that we've always helped with, F5 has always helped with, some of those are going to take a long time and maybe never go away, those waterfall apps. But some of them over the next year or two will move to more of an agile type of process or an agile development. The hundreds or thousands of apps that customers have that are just small, not used by many people, they're going to maybe all be totally in an agile type of environment, agile development type of environment. And many of them are starting there, right? The other thing that we need to talk about is with Supernet Ops, the thought process was, and this is kind of as we move towards this stuff, the NetOps people and the DevOps are going to kind of merge together a little bit. They may not quite overlap that much. That may be a little bit forward thinking than what really ends up happening, but we need to help with that. And our thought is that it would be hard for us to drag these guys back this way and talk the same language. It's just not maybe as possible to make that happen. But for the NetOps guys, we can go talk to them and say, hey, we've always talked to you guys and tried to help you in your jobs. This is coming. Whether you want it or not, this is coming, and the DevOps groups are getting more and more power. So if we can, what we'd like to do is help you understand why they're doing that stuff and play a role. Right? So we're trying to, Supernet Ops, the idea is we're trying to bring the NetOps folks a little bit towards the DevOps folks and help them learn, understand, grow into that role. They may never, a lot of times when I used to ask the question, how many of you are network admins, a lot of hands would go up, right? How many of you do coding? A lot of those hands would go down. I did coding for a while, I don't want to do it anymore, right? They may not end up becoming DevOps people, but at least their role hopefully will stay around and be able to kind of be the intermediary between. So that's the idea. Good? Questions? Okay, so last thing we want to talk about before we get you to a lab is the REST API and then the Postman tool, just so you know what you're seeing in the lab and what we're going to have you go look at. REST API, if you start looking at it, and you're familiar with, I know many of you are pretty familiar with Big IP, start looking at the code in the REST API, it's going to look somewhat familiar. That's because it's based on the TMSH commands. We built the REST API off of that. Okay? Kind of makes sense, right? So all that TMSH knowledge that you have isn't going to go to waste. When you're talking about REST, it's based on HTTP and JSON. It uses a lot of the same traditional HTTP verbs like get, post, put, patch as an example. And then there's attributes and values that you're going to enter into the REST API call that you make. Okay? Here's a couple things that we need to talk about. You'll do these different HTTP verbs to do different things with what are called collections and resources. You can do the typical CRUD, create, read, update, and delete functions using those HTTP verbs, and use it in the same way you would a typical application programmer would, right? What am I missing, Chris? I think we talked about that. The responses should be hopefully somewhat familiar to you because they're the typical HTTP response code. So 200 OK, you're used to that. 404, maybe that's worth talking about for a second. So you get a 404 in the past, that's always been a bad thing, right? The file not found, somebody screwed up the website last night. In this case, maybe what the DevOps person is doing is they're going and checking to see whether something's there on the site or not, or a config, like is this pool member there already, or no, I need to add it. So if they get a 404, that might be just part of their code checking to see whether something is created or not. Okay? So maybe a little bit different context for some of these status codes that you get back, but very similar to what you're used to with HTTP commands. Good? So here's an example. We got of a typical REST URI. We're going to go to the management port. Okay, and then does this look familiar? TM for traffic management, right? And then LTM. In this case, we're going after something underneath the local traffic module or manager part of the product. We're going to do a pool. That's the collection level. And then things after that are resources. Remember under last week when we talked about BigIQ, I said when you created a pool on BigIQ, that it uses the REST API to make that call to a Big IP to create that pool. And if you remember, it created the pool first, and then we had to go down and create members. Members are a sub-collection of the pool. So you're able to do both, right? But you have collections and then sub-collections that you might need to get into, depending on what the object is, right? So in some cases, it might be a sub-collection that you're actually looking at. Give it a name, and this is if you're familiar with the partitions idea in Big IP. You're gonna put most of this stuff typically in the common partition, but you could do other partitions if you wanted to, right? When you're doing the naming. When we go into lab, we're going to go to the management IP address /management/TOC, and you're now in the REST API, and you can navigate around in there. We're going to enter stuff in this little search box up there and narrow down what we want to go look at. And under /net, what would you think would be under net? Network stuff, under the GUI, right? So we have self IPs, we have VLANs, we have interfaces, all that stuff is where we would go, and you'd be able to see REST calls. We're going to actually look at some of those things in lab here in a minute. So you can do the search box and then go deeper For instance, there's the self IPs, VLANs would be down farther, the routes, all that stuff is here in this table of contents for the REST API. And we'll go mess around with it in lab here in a minute. When you're doing this interface here, this is by the way, this is not really the lab exercises on this stuff are not really intended to have you learn how to issue REST commands other than just exposing you to what the syntax would be. Right? It's just we're trying to make you aware that this is here, and this is one thing you could go into and get a lot of the actual syntax of the REST call, and you could copy paste this. So you could copy all this and then paste it into when we create under the plus sign there, create a new self IP and just change, in this case, like the actual addresses that we're entering. So copy paste, right? This is the REST code for that particular self IP. We could dial in, grab that REST API call, and then just modify it how we want. Okay? So it's more just to make you aware this is here. This is not how customers are using the REST API calls. Right? It's just a reference, yeah.
For specific REST APIs.
Yeah. Yeah.
So people aren't going to the TOC text.
No. Okay. So we'll do it as an exercise, but not intended for you to use it that way. Just exposure. Okay. The other thing we're going to do is we're going to use a tool called Postman. There's other tools we could use. It's just a tool that has a bunch of things that are scripted already for us, doing a lot of these calls, and we're just going to go through and use some of these calls to issue some of these REST API calls to Big IP and create objects, get on, log on, configure the box, in steps. And it's intended. Same thing, not for you. We aren't trying to teach you Postman as the only tool. We're trying to show you how customers might actually use this, where they're going to take all these sets of code that create objects on a Big IP or create their applications in some public cloud, and then that is their build for the next version of the app, right? And they modify this, they modify that. Now we got a new app. Make sure the app works, and then delete the old one. Pave and nuke. Right? No rollbacks. So we'll use Postman. The couple things that are already done for you, but normally you would have to do is go to the import button and import what's called a collection. In your guys' case, it'll already be done, and then we'll run steps over on the left-hand side of that of the GUI. And then the other thing and we want you to go look at what's actually in some of these steps. We'll look at both the headers and the body in many cases of what the REST API call looks like. So we'll go in lab, navigate through that and look at it. The other place you need to navigate to periodically, or not periodically, but when you're setting up is what's called the environment up here in the upper right. And a lot of times what you use the environment variables for are, I'm going to use this particular setting over and over and over again. Like, what is the management IP address of the Big IP? I'm going to set that in a variable, and then I'm just going to refer to the variable after that. So we'll do that a little bit. We'll mess around a little bit with the environments setting in this lab.
Is Postman an open source tool? I
do not know the answer to that. Do you know? Postman open source tool? What's that?
I believe it's meant to. Yeah,
Yeah, you can download it. Does it work for Mac too? Or?
yeah.
Yep. Absolutely. Yep. Yeah, you can. We'll have it running on actually a Linux client, but I've run it on Windows and I've seen people run it on Macs. So.
Yeah, there's browser integration for the full cloud. Yep.
Any other questions? Okay. Yeah.
So, do F5 for the REST API of Big IP is uncontrolled? Is it right?
Yes. So you'll hear this REST API referred to as the Big IP I control REST API. That's what we call it. Okay. So with that, I'm gonna tell you the lab. At a high level, we want the lab. Next step is for you to go do the lab. At high level, you're going to explore that iControl REST API first. Then we're going to set up BigIP using Postman, and it already has a pre-canned set of calls to go do things on a BigIP. We'll mess around with that. And then final steps are to actually create an LTM config on that BigIP using the Postman steps, and then go test it. Make sure it works. Okay? So ready, set, and we haven't done a break yet, so break and lab for a while.